Good Friday morning to you, students. Hope you guys have had a good week so far. And I am glad it's Friday. I'm sure you guys are too. Oh, I love Fridays. Fridays are the best. So hope you guys have a good Friday, a good weekend. And of course, except for Ashley. Ashley, you got a test to make up today, so please don't forget that. You have a makeup test today, so please get that taken care of. And from now on, all incompletes will turn to zeros unless you're absent on Friday, or unless you have a really good reason. Maybe you missed some days this week, but email me and let me know, or call me or something, please. But your homework is due today. And let's see, there'll be a test next Tuesday. And again, Ashley, be sure and take your makeup test by today. Please don't forget to do that, okay? And then there's something else. Oh, you need to turn in yesterday's homework. You had homework last night, Thursday night. Please turn that in at this time. Now, when I am able to give you 2 days to review for a test, I'm going to do it. And we have plenty of time. We are doing great on time. And I'm going to give you a very large review sheet. I'm not sure exactly how many problems. I know it's 50 some. So 50 some problems. And if you want 5 bonus points on the test, I would do it. The last test we had, 2 of you did it and 2 of you did not. So please work on the review sheet. You have all class period today, all class period on Monday, and over the weekend to work on this. And you've got a really cool video featuring Mr. Earhart to listen to if you need help with this review sheet, whether it be over the weekend or during class, okay? So with that in mind, let's start reviewing. Oh, and by the way, I went to YouTube and looked at the past 3 or 4 homework assignment videos, and you know how many views those videos had? Yeah, 0. So, not happy. But I do that for you guys, so if you don't watch it, it's fine. I mean, it's not a big deal, but I really feel like it would help you. Unless you're really getting the homework without any help, that's fine. But I think it'd be wise to allow those help videos to help you with your homework. Okay. So moving on, the review sheet for today is right here. So please copy this review sheet down if you would. Here's your review sheet. I've said this 100 times. If you try to copy down the definition, you're just not going to be able to do it. So please don't try to. You're wasting class time, okay? You need to know what an equilateral polygon is, equiangular polygon, regular polygon, theorem 8.1, and theorem 8.2. That's not all of them, but that's part of them, okay? So please take a second and copy those down. Not the definitions, not the actual theorems. You should have all of these in your notes. Equilateral polygon, equiangular polygon, regular polygon, theorem 8.1, theorem 8.2. Okay, I'm going to switch pages in a second, so if you need to pause the video, please pause the video. You need to know the definition of these words. Circle. Whoa, it's not good. Circle, radius, diameter, circumference, central angle, and sector. You need to know the definitions of all of those words. They will be fill in the blank like usual. I'm going to pause for a second. Don't try to write the definitions down, please. Just write the words down. Circle, radius, diameter, circumference, central angle, and sector. You need to be able to fill in the blanks on these definitions, okay? Alright, I'm going to switch pages, so if you're not done, please pause the video. And nothing wrong with that, by the way. I hope you don't feel rushed. Remember, you can always slow me down, but you can't speed me up. So I'm just going to go fast and let you pause the video if you need to. Here are the pages. Page 460, 9 through 40 all, and then page 462, 1 through 23 all. And so This is your review sheet. It's 50 some problems. You have all class hour today, all class hour on Monday. Over the weekend, I'm sure you have at least time of the weekend to do 10 problems. That's 5 a day, 5 on Saturday and 5 on Sunday. And that would leave about 40. You could do 20 in class today and 20 on Monday. You're going to see they're not that difficult, okay? So the rest of the video is me working out these problems. So I don't care if you play the video and listen to me. I don't care if you just stop the video and start working on these and then fast forward the video to the problems you're stuck on. All of that is up to you. But in about 1 second here, I'm going to hop on to number 9 and I'm going to get started. Okay, so page 461, 9 through 40, page 462, 1 through 23. And by the way, Mr. Harmon's going to play this exact same video for you again on Monday. Okay, this is it. And then I will see you on Tuesday in person to go over your test. Okay, please open your book to these pages. Get started. I don't think this is right here. Okay, this is not right. This should be page 464. Okay, this is not right. Page 464. All right, so we better fix that. And I hope you got that. All right, page 464. All right, here we go. Let's take a look at number 9. Number 9, or numbers 9 through 12. You were saying yes, it's regular, or no, it's not. Okay, a regular polygon has to have all 3 sides congruent and all 3 angles congruent. Well, look, this side here is not marked congruent. This angle up here is not marked congruent. So no, we do not have a regular polygon. We might. I shouldn't say we don't. We might, but we don't know for sure that we do. So the answer is no. Number 10, I did not write that object down. That figure is just too complicated to try to draw. But if you'll look, every single angle has a congruency mark and every single side has a congruency mark. Yes, number 10 is regular. It is a regular polygon. Moving on to number 11. Number 11. Well, students, look. This side right here I'm circling is not congruent to this side here, is it? Of course not. Not at all. So right away we can see, no, we do not have a regular polygon. And then number 12, I'm not going to try to draw that figure, but look, I don't see any of the angles marked congruent. None of them. All the sides are congruent, but in order to have a regular polygon, all the angles have to be the same and all the sides have to be the same. So no for number 12. No. Okay, moving on to number 13. They want us to find this missing angle. Now, the only way to do that is to know what all of these angles are when you add them up. How many sides do I have? 1, 2, 3, 4, 5. We know how to find the sum of all of these angles. It's 185. There's 5 sides, so 5 minus 2. Remember, it's always n minus 2. In this case, it's 5. Not what I wanted to do. Not what I wanted to do. There we go. In this case, it's n right here. And so 180 times 3 would be 540. So if you add up all of these angles on the inside, you'll get 540. So we have 121, 100, 124, 104. That would be 449. So let's subtract out 449, and we should get 91 degrees. 91 degrees for this angle right here. All right, let's try number 14, done the exact same way. We have 6 sides. 1, 2, 3, 4, 5, 6. So let's find the sum of the interior angles. 6 minus 2. So 180 times 4. That would be 720 degrees. So if you add up all 6 of these angles, you'll get 720 degrees. Now let's add up these 5 known angles that we have, and let's see what we come up with. 2, 1, 5, 6, 9, 592. So all 5 of these angles here add up to 592. So let's subtract 592 out, and let's see what we get. 8, that should be 128, I believe. Yep, 128 degrees. But But if you'll notice that problem number 14 and problem number 13, notice on number 13, there's no way you can find this missing angle until you find the sum of all of those interior angles, or what their sum should be. Same thing with this. I had to find what the sum would be of all those angles first before I can actually find that missing angle. Now on number 15, exterior angles, their sum always equals 360 degrees, always. So here's my exterior angles: 1, 2, 3, 4, 5. There's 5 angles. I know 4 of them. Okay, students, I'm back. Sorry about that. Had a little meltdown with one of my children. Whew, okay. So I forget where I was. I have no idea. All right, I think I was saying that the sum of all the exterior angles is 360. So we're going to add all these angles up. Notice this is 90 degrees right here. So we have 67 for one angle, 90 for one angle, 81 for one angle, and 72 for another. 0, carrier 1, 310. Now remember, the sum of exterior angles never changes when it's a convex polygon. It's always 360. So if these 4 angles add up to 310, well, 360 minus 310, the other angle has to be 50 degrees. 50 degrees. All right, let's take a look at number 16. Let's find the area of this polygon. We have a side of 8. Well, it's a square. All 4 sides are congruent, so we have an 8 here. So the answer is 64 square units, or square inches. Let's take a look at number 17. Number 17. Hold on one second. All right, number 17. Let's find the area of this rectangle. We have a length of 12 feet and a width of 6, so the area would be 72 square feet. 72 square feet. Let's take a look at number 18. Number 18, let's be a little interesting here. We're going to have to find the length of this rectangle here, excuse me, the area of this rectangle and the area of this square. Now, the square is obviously 3 by 2. So this area is 6. Now the rectangle, be careful on this, the rectangle has a length of 7. We can see that right here, a length of 7. However, okay, on this rectangle right here, let's see, we have a length of 7. Now, please don't think that this side right here has a length of 5. That's not correct, okay? 5 goes for this whole side right here. Well, Mr. Earhart, how can I find this little bit right here then? Well, it's really not that hard. If you'll watch this for a second, do you see that from here to here we have 2? And so that means if I go straight down from here to here, I would have to have 3, which means this right here would also have to be 3. So this length, or this width right here, is 3. So this rectangle's area is 21. So this rectangle has an area of 6. This rectangle has an area of 21. Add them together and you get 27 square units. All right, and that's the area of number 18. Let's move on to number 19. Number 19. All right, let's find the area of triangles, okay? So 1/2 base times height. That's how you find the area of triangles. Let's see if we can't quickly do this. Do this. All right. Okay, so we have 1/2. My base would be 11, and my height would be 8. By the way, I know my height is 8 because notice this line right here is perpendicular to my base, you always want your height to be perpendicular to your base. Okay, so leave your fraction for last. 8 times 11 is 88, and then 1/2 times 88 is 44 square units. So that's the area of the triangle. Let's take a look at number 19 real quick. All right, let's see here. Now this problem here is kind of interesting because if you'll look, they don't give you the height. They don't tell you what the height is. Now, what I'm going to do here is kind of watch this. You can turn your book if you need to, okay? What I'm going to do is I'm going to take this whole triangle and turn it like that, there. And now, of course, my numbers here are not quite, they're not right because they're still turned. That's a 2 and that's a 3. But do you see what I did? I turned this triangle so that now I have 2 sides that are perpendicular and one of the sides is the base. So with that in mind, I'm now ready to use my formula. So the area of this triangle is 1/2 base times height. I saved my fraction for last, so 1/2 times 6, and 1/2 times 6 is 3. 3 square units for number 20. All right, number 21. Let's go ahead and find the area of this triangle. Here is the formula we would use. 1/2 base times height, so 1/2, my base is 13, and my height is 9. And I'm going to go ahead and save my fraction for last. This would give you 117. And then if you take 117 times 1/2, I believe you get 58.5 or 58.5 square units. Okay? And that's number 21. Moving on to number 22. Let's find the area of this triangle. The area. Well, in order to find the area of a triangle, it's 1/2 base times height. Obviously, the base in this triangle would be 8.5. I'm going to go ahead and put 8.5, which is the same thing, and my height is 11. Now, I'm going to go ahead and leave my fraction for last. I'm going to multiply 8.5 times 8.5, and what I'm going to get would be, let's see, 92, 93.5, or 93.5. Okay, that's 8.5 times 11. Use a calculator if you need to. And now 1/2 times 93.5 is going to be 46.75 square units. 46.75 square units. All right, number 23. They don't give you a picture, but they want you to find the base of a triangle. What they do is they give you the area, and the area is 117, and they give you the height. The height of the triangle is 9, and they want you to find base. We'll put a blank there. Well, let's go ahead and use our formula. Let's pull it down here. There we go. And now let's see. We have area equals 1/2 base times height. So where the A is, I'm going to substitute 117. And where the B is, I'm going to leave that B. And then where the H is, I'm going to substitute 9. Okay? Now, when solving equations, you know to simplify each side. There's no way you can simplify 117, so we leave that alone. But you can simplify this over here. Forget the fraction for a second. Let's just pretend we have something in algebra like 3x and then 5. Well, you could have written 15x. 3 times x times 5, multiply 3 times 5, that's 15, and then times the x. We can do the same thing right here with this problem. We have 1/2, then b, and then 9. Well, I can multiply, it's 1/2 times b times 9. I can multiply 1/2 times 9, and when I do, I get 4.5b. 4.5b. And now we're going to divide both sides by 4.5. And the base will be 26. 26. So 26 equals your base. 26. All right, let's take a look at number 24. In this problem, they tell us that a triangle has an area of 81, and it has a base of 18, and they want us to find the height. All right, so let's go ahead and use our formula here that we have. So area equals, And now where the A is, I'm going to substitute 81. Where the B is, I'm going to substitute 18. And where the H is, I'm going to leave it H. Now we can't simplify the left side. 81 is 81. However, we can simplify 1/2 times 18. That would be 9H. 1/2 times 18 times H would be 9H. And now we divide both sides by 9, and your height equals 9. So your answer is 9. Okay? That's number 24. Let's move on to number 25. On 25 through 29, we're going to be dealing with parallelograms and rhombi. And so let's take a look here at number 26. They want us to find the area of this parallelogram. All right, the area of this parallelogram. We know by now, in order to find the area of a parallelogram, it is base times height. Or hopefully you know that by now. Base times height is the formula for finding the area of a parallelogram. So, looks like in this problem here, the base would be 8, and the height, of course, has to be perpendicular to the base. The height would be 7. So the area would be 56 square units, or in this case, square feet, 56 square feet. All right, number 26, we're going to use the exact same formula. Area of a parallelogram equals base times height. So area equals your base is 6 and your height is 10. So your area is 60 square centimeters. 60 square centimeters. Moving on to number 27. Now this is interesting. Please don't miss this. Notice all four sides are the same length. So this is a rhombus. Okay? Do you remember how to find the area of a rhombus? Area equals 1/2 diagonal 1 times diagonal 2. Pretty interesting, okay? Take a look at that for a second. So how do I know we had a rhombus? Well, anytime you have a quadrilateral in which all four sides are congruent, you have a rhombus automatically. I don't care about anything else. So having said that, do you see how I've got a 9 written down here from this length to this length? Well, that's also, if I were to draw a diagonal going across, that would also have a length of 9. And if I were to draw a diagonal going down like this, connecting these two vertices, this whole length right here would be the same as this 5 over here, so 5. So one diagonal has a length of 5, one diagonal has a length of 9. So it looks like to me we're simply going to have 1/2 times 5 times 9, or in other words 1/2 times 45, which will be 22.5. 22.5. All right, and that's number 27. All right, let's take a look at number 28. Number 28. A parallel. Oh, okay, now we're going to be going backwards here. So they're going to tell us the area of a parallelogram is 135, and they're going to tell us that the base is 15. And I'm assuming they want us to find the height. Yes, find the height. So we already know what our formula is. Excuse me for yawning. So for area, I'm going to substitute 135. For B, I'm going to substitute 15. For H, I'm going to leave it H. We're going to divide both sides by 15. And when we do that, we will get 9. So the height of the parallelogram is 9 inches. Now let's take a look at number 29. Number 29, they do not give us a picture, but they do tell us that the area of a parallelogram is 121. And they also tell us that the height is 11 meters. The height is 11, so find the base. Well, here's our formula we use when we're dealing with parallelograms and areas. And so we know for A we can substitute 121, and we know for B we're going to have to leave B of course, and then of course H would be 11. Now, B11 would of course be the exact same thing as 11B. I mean, B times 11 is the same thing as 11 times B. So we're going to divide both sides now by 11. And if we divide both sides by 11, the base would be 11 meters. 11 meters. Okay? All right, moving on to number 30. Number 30. Now we're going to start finding the area of trapezoids. Area of trapezoids. And here is this formula right here. We would have a 1, 8, 1/2 here, and then an H, and then a base 1 plus a base 2. Now please don't forget, in a trapezoid, the bases are always the parallel sides. Okay? The bases are always the parallel sides, so please don't forget that. All right, here we go. Looking at this trapezoid, it looks like the parallel sides would be 6 and 10. Those are your bases, and 7 would be your height. So A equals 1/2 times 7. That's my height. And then here, I'm going to go ahead and put 16, because base 1 plus base 2, 6 plus 10, would give you 16. So I'm trying to save a step there. Now I'm going to save my fraction for last. So I'm going to have 1/2 times 112. And then 1/2 times 112 would be 56 square millimeters. 56. That's your area of your trapezoid. Let me grab a drink of water here. And let's move on to number 31. Number 31. Okay, we're going to find the area again of this trapezoid, so I'm going to go really fast here. It's pretty much the same thing. Area equals 1/2 times the height. The height is 6. And my two bases added together, 4 plus 8, would be 12. I'm going to save my fraction for last, so 6 times 12 would be 72. And then multiply 72 by 1/2, and we will get 36 square feet. 36 square feet. Let's take a look at number 32. Number 32. Okay, once again, we're going to find the area of a trapezoid. And so for H, I'm going to substitute 8. That is the side that is the segment that is parallel to the bases, or perpendicular to the bases, excuse me, forms a right angle. And then my bases are the parallel sides. So we're going to add them together. We should get 18. 7 plus 11 is 18. And now we're going to save our fraction for last. We're going to multiply 8 times 18, which is 60, let's see, 64 carrier 6, 144, I believe. So 8 times 18 is 144, and then 1/2 times 144 would be 72 square centimeters. 72 square centimeters. And then number 33. Now students, be careful here, okay? Look, just stick to the formula and do what you've been taught. The height, first of all, always has to be a line. It has to be the line that connects or is perpendicular to both of the bases. Now the bases have to be parallel sides. That's why this side right here and this side right here, they cannot be the bases. They're not parallel at all. But notice these two sides here are parallel. Okay? So because those two sides are parallel, they're my bases. If they're my bases, then this must be my height right here. One more thing. Hopefully this will help a little bit. It's not what I meant to do. Okay, now let's turn this thing and look at that. So once we turn it, it's kind of easier to see. These are your bases. This is your height. Okay? All right. So here we go. 1/2 times my height, which is going to be 2. And then my bases added together would be 3 plus 4. That's 7. I'm going to save my fraction for last. So 2 times 7 would be 14. And 1/2 times 14 would give you an answer of 7 meters squared. 7 meters squared. Okay, moving on to number 34. Number 34, now here we're going to go backwards. We have a trapezoid, and they give us the area of the trapezoid. The area is 100 square yards. 100 square yards. The lengths of the bases are 9 and 11. Find the height. Find the height. Well, here's the formula, excuse me for yawning, that we're going to use. So for A, I'm going to substitute 100. For 1/2, I'm going to leave 1/2. H is my unknown, so I'm going to leave that H. And then right here in the parentheses, B plus B, I'm going to go ahead and put 20. 9 plus 11 is 20. Now, we're solving for H. Notice that you cannot simplify the left side, but you can simplify the right side. 1/2 times H times 20. So 1/2 times 20 would be 10H. Now divide both sides by 10, and ten equals H. That's your height. And so your height would be 10 yards. 10 yards. All right, moving on to circumference and area of circle. Let's see if we can't take care of these very quickly. All right, here we go. Let's find, first of all, we'll do it from side to side. Circumference equals pi d, and area equals pi r squared. Okay, so let's first of all find the circumference. Students, if my radius is 13 from here to here, then obviously the entire diameter has to be 13 and 13, so it has to be 26. So circumference equals 3.14 times the diameter, which would be 26. And the answer for 35 would be 82 inches. We are rounding to the nearest whole number, so 82 inches. Now let's find the area of this circle. So area equals and there we go. So first of all, for pi, we're going to substitute 3.14. For the radius, we're going to substitute 13. And so the area would be, and with using calculators, this should be pretty simple. 13 times 13, you do want to do your powers first. You do want to solve your powers first. So 13 squared, 13 times 13 is 169. And then 169 times 3.14. The answer would be 531 square inches. 531. Okay? All right, let's continue on to number 36. 36. All right, let's start over here with the circumference. The circumference would equal, let me move something here. Give me 1 second, please. Okay, the circumference would equal pi d. If the radius is 1, then the other radius is 1, the whole diameter is going to be 2 all the way across, obviously, so my diameter is 2. So circumference is 3.14 times 2, so the circumference equals 6.28. Alright, now let's come over here and find the area of the circle. Area equals pi r squared, so area equals 3.14 times 1 squared. Square the 1. 1 times 1 is 1, and 1 times 3.14 is 3.14. I think they want us to round to the nearest whole number, so the answer here would be 3, and the answer over here for the circumference would be 6. Those are the nearest whole numbers. All right, moving on. Number 37. All right, the circumference is pi d, so circumference equals 3.14 times the diameter. And if you use your calculator and type in 3.14 times 8 and then round to the nearest whole number, you're going to get 25 feet. For the area, it's going to be pi r squared. So for pi, I'm going to substitute 3.14. Now watch what I put for the radius. I'm going to put 4 for the radius, because if the whole diameter is 8, then cut that in half. From here to here is 4. So the radius has to be 4. So we first do our powers. You should know that by now. You do not multiply 3.14 times 4. That is incorrect. You first square your 4, and you'll get 16, and then 16 times 3.14, rounded to the nearest whole number, will be 50. 50 square, let's see, 50 square feet. All right, let's take a look at number 38. Number 38. Now on number 38, we are still finding the circumference and the area. Seems like we've done 100 of these now, but here we go. Circumference equals pi d. So circumference equals 3.14 times your diameter, which is 14. You can see that right over here. Diameter is 14. And if you multiply those correctly and round to the nearest whole number, you will get 44 centimeters. Now, the area, of course, is pi r squared. And so for pi, we're going to substitute 3.14. For r, we're going to substitute 7. If your diameter is 14, then your radius from here to here is 7. And you do solve your powers first. So we really have 3 area equals 3.14 times 49, because 7 squared is 49, and when you multiply those two numbers together and round to the nearest whole number, you will get 154 square centimeters. All right, moving on to number 39. Number 39 has no picture. It just says that you have a circumference of 50. And actually, I think I just found a mistake in the book. Isn't that funny? Look at number 39. It says a circle has a circumference of 50 square feet. That is wrong. Circumference is never square anything. So the book is wrong. It should say a circle has a circumference of 50 feet, and they want us to find the radius, question mark. Well, they give us circumference, so we're going to use our circumference formula. Circumference is pi d. So where circumference is, I substitute 50. Where pi is, I substitute 3.14. And then, of course, I have d right here. Well, let's divide both sides by 3.14. And if we get that, if we do that, we're going to get approximately, I'm rounding now, to the nearest whole number, you're going to get 16. Okay. Now I rounded that to the nearest whole number, so 50 divided by 3.14 is going to be 16 point something, but we round to the nearest whole number. Now hold it, that's d. I divided both sides by 3.14, that's d. We're trying to find radius. So think about it, if I've got a circle that's got a diameter of 16 going all the way across, then obviously the radius is going to be half that. The radius is going to be 8. So r equals 8. There we go. Moving on to number 40. Number 40, they do not give us a picture. They tell us a circle has an area of 380 square centimeters. Find the radius, question mark. Okay, they give us area, so we know we're going to use this formula right here. Area equals pi r squared. For a, we're going to substitute 380. For pi, we're going to substitute 3.14. And then for radius, well, that's what we're looking for. We're not going to substitute anything. So we're trying to find what r equals. So first of all, we're going to divide both sides by 3.14. Okay? So we're going to divide both sides by 3.14. And I'm estimating, I don't have a calculator in front of me, so please understand that. So you should get out, no, again, I'm going to put approximate, okay? So if you're not getting exactly 121, you should be close to that, okay? But I do not have a calculator with me, so I'm estimating that. So we divide both sides by 3.14, and we get approximately 121, and then hold it. We have r squared. I don't want r squared, I want r. Well, the only way to get rid of an r squared is to take the square root of r squared. But if you take the square root of one side, you've got to take the square root of the other side. And so the square root of r squared is r. The square root of 121 is 11. So there we go. Number 40's answer is 11 centimeters. Okay, moving on to number 1. Moving on to number 1. They want us to draw a concave octagon. That means it's got to do something where it indents like that, okay? So let's see if we can do this. It has to have 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Wow. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8. That is a concave octagon. All right. Let's take a look at number 2. They want us to do a convex equilateral hexagon. I am going to cheat. Look at that. All right. That is a convex equilateral hexagon. 6 sides. All the sides are the same. And it's convex. Okay, moving on to number 3. A regular triangle. Now, regular means all of the sides are congruent and all of the angles are congruent. So, looks pretty good to me. There we go. Regular means, I'm going to go ahead and mark it for you. Regular means all of the angles are congruent, so we'll put those marks. And it means all of the sides are congruent. Moving on to number 4, a regular pentagon. Again, I have no pride whatsoever. I'm going to cheat. Regular pentagon. That looks pretty good. All the angles are the same and all the sides are the same. Okay? That's a regular pentagon. On to number 5. Number 5. We are finding the missing angle. Now, in number 5, we have how many sides? 1, 2, 3, 4, 5, 6 sides. So if we have 6 sides, we got to find out what all 6 of these angles would add up to. So 180, 6 minus 2, 180 times 4. All 6 of these angles added together will equal 720. So we better find out what these 5 angles add up to so we can find that missing angle. 15, 16, carry 1, 6, 7, 9, 5. That would be 124. So if you take 720 and subtract out 596, you should get 124 degrees for this question mark right here. Moving on to number 6. Ooh, exterior angles. What do those always add up to? Always 360. I don't care how many sides we have. So cool. So this isn't too bad. We have 65 degrees right here. We have 62 degrees right here. We have 90 degrees right here. And we have 50 degrees right here. Add those up and you get 267. Now all these angles together have to add up to 360, so we're going to take 360 and subtract out 267, and we should get 93 degrees, which is the answer to that question mark right there. Moving on to number 7. Find the area. Well, guys, it's pretty simple. This is 7 and this is 7, so the area is 49 square feet. Moving on to number 8. We know this side is 4 and this side is 5, so the answer would be 20 square centimeters. Moving on to number 9, a triangle. 1/2 times the base, which is 7, times the height, which is 4. Save my fraction for last. 7 times 4 is 28. 1/2 times 28 is 14 square meters. Square meters. All right, let's find the area of a parallelogram. Well, the area of a parallelogram is simply base times height. Base times height. So the base of this parallelogram is 8 and the height is 13. And so the area would equal, let's see, 104 square inches. 104 square inches. Number 11. Oh, it's a rhombus. Rhombus. Remember that formula for a rhombus? Area equals 1/2 diagonal 1 times diagonal 2. Now, if this length right here is 10 going across, then that tells me this diagonal right here would be 10. And if this length right here is 12, then that tells me the diagonal right here would be 12. So, to find the area of this rhombus, I would have 1/2 times 10 times 12. That would be 1/2 times 120, which would be 60. So the area of this rhombus would be 60 square millimeters. 60 square millimeters. Okay, moving on to number 12. Number 12. All right, we have a trapezoid. The formula for the area of a trapezoid is 1/2 height. And then we add our two bases together, base plus base. Bases are always your parallel sides. So my height would be 6, and my bases added together would be 15. I'm going to save my fraction for last. So 6 times 15 would be 90, and 1/2 times 90 would be 45. So the area of this trapezoid is 45 square yards. 45 square yards. All right, number 13. Looking ahead to number 13, they want us to find the area of this kind of weird shaped object. Well, first of all, students, I know that this little quadrilateral here has a length of 3, but I don't know what this side here is. But if you'll think for a second, this whole side all the way across is 7, right? And so if we know from here to here is 4, then we know from here to here also has to be 4. So if from here to here is 4, then obviously from here to here it must be 3 to give you a total of 7. So the area of this square right here, 3 times 3 would be 9, and the area of this rectangle would be 4 times 9, that would be 36. Add those two together, and the area of this figure for number 13 would be 45 square meters. 45 square meters. And then number 14, let me get a drink of water here. Excuse me, sorry. This is going to be the area of a triangle and the area of a trapezoid. So I think it'd be wise, first of all, for us to draw the triangle off to the side like this. My height is 3. My base is 5. So let's find the area of this triangle. It'd be 1/2 base times height, 1/2 times 5 times 3, which if you type all that in, trust me, you'll get 7.5. So the area of the triangle is 7.5. Now we got to find the area of this trapezoid. Okay. Well, we can see the parallel sides are your bases. They're 6 and 5. And we can see the height going straight up and down is 4. So the area of the trapezoid would be 1/2 h b plus b. So that would be 1/2 times 4, and b plus b would be 11. So 4 times 11 is 44, and 1/2 times 44 is 22. That's the area of this object. So if we add these two areas together, the area of the triangle and the area of the trapezoid, if you add them together, you'll have your answer. So 22 plus 7.5, your final answer is 29.5 square feet. Square feet. Okay, let's move ahead to numbers 15 and 16. For 15, we're going to find the circumference of this circle. That's pi d. So 3.14 times 4. If your radius is 2, your diameter is 4. And if you round that to the nearest whole number, you'll get 13. Now the area of this circle would be area equals pi r squared. So 3.14 times 2 squared. And of course you do your powers first, so it would be 3.14 times 4, and that would give you 12.56. We're going to round that to the nearest whole number. So the answer is 13. Whenever a circle has a radius of 2, your circumference and area will be the same. That will always happen when your radius is 2. Okay, moving on to number 16. Number 16. Okay, number 16, they want us to find the circumference. That would be pi d. So 3.14 times 6. And that would be, I think, 18.84. So that would round to 19. So the circumference is going to be 19 for number 16. The area is going to be pi r squared. So the area equals 3.14. Now if the whole diameter is 6, then from just here to here, the radius has to be half of that, which is 3. So 3 squared. So you would end up multiplying 3.14, your pi, times 9. And that would give you, let's see, 36 carry 3, 2 carry 28, I think at 28 point something, and you round that to the nearest whole number, it would be 28 square meters. Okay, yesterday I told you how to find I taught you how to find the areas of sectors of a circle, parts of a circle. And what I said was, is step 1, find the area of the whole circle. So the area of the whole circle would be pi r squared. That would be 3.14 times 5 squared, and that would be 3.14 times 25. Now I apologize for wasting your time. I do not have a calculator, nor can I do this in my head. So very quickly, 27, 15, 6, 2, 8, 0, 5, 8, 7. So the area is 78.5. Then I told you to find the fraction of the shaded area. Find the fraction. And the fraction would be 130 degrees over the complete circle, which is 360. Divide both sides by 10, and you get 13 over 36. And then lastly, I told you to take whatever you got from step 1 and whatever you got from step 2 and multiply them together. So 78.5 times 13 over 36. All right, and if you type that in correctly and round to the nearest whole number, you will get 29 square feet. 29 square feet. So let's apply that again to this now, okay? Let's practice. Step 1, find the area of the whole circle, and that's pi r squared. So 3.14 times 8 squared, so 3.14 times 64. And I will have to work that out off to the side. I apologize. So 3.14 times 64, 6 carry 1, 5, 12, 24 carry 2, 8, 18, 9, 6, 0, 2, 0. Okay, so 200.96. So the area of the entire circle is 200.96. Now, step 2 is to find the fraction of this sector. What is the fractional part of this sector? And of course your degrees are 60, so we're going to put 60 over 360, cross off your zeros, reduce 6 over 36, that's 1/6. And then step 3 is to take your answer from step 1 and your answer from step 2 and to simply multiply them together. So the area of the whole circle is 200.96 times the fractional representation of the shaded area, which is 1/6. Multiply step 1 times step 2, and if you do that correctly and round to the nearest whole numbers, you will get 34 square millimeters. 34 square millimeters. All right, moving on to number 19. Now this is going to be really tough, okay? What we're going to have to do is find and I would not give you one of these in the test, but it's still good that we try this, okay? We're going to have to find the area of the entire rectangle, and that's so easy to do, isn't it? I mean, my goodness, we have a length of 16 and a width of 12. So we can take 16 times 12, and that'll give us the area of this whole entire rectangle, okay? So that's the first thing I'm going to do. So 12 times 16, 72, 192. So the area of the entire rectangle is 192. Now, think about this, guys. If I find the area of the circle, this part right here, if I find the area of the circle and then subtract it out from the whole area, what I'm left over with is the blue part. So that'll be the area of the blue part. Think about it. 192 is the area of this whole thing. Circle, shaded area is the whole rectangle. Okay? There. And then what I'm going to do is I'm going to find the area of the circle. Now watch my eraser here. And I'm going to subtract, well, I didn't mean to do that, that's for sure. I'm going to subtract out the area of this circle. And when I subtract out the area of the circle like this, then what I'm left over with has to be the area of just the blue stuff right here, or the shaded area. Okay, so that's not, whether you understood that or not, I don't know, but that's what we're going to try to do. Okay. Okay, so the area of the entire rectangle is 192. What is the area of the circle? Well, let's find out. Pi r squared. So, oh, did not mean to do that. Let's go like that, and no, that, and that, and that. All right, so the area of the circle is pi r squared. So 3.14 times 6 squared, that'd be 3.14 times 36. 3.14 times 36. Now, I'll have to do this quickly off to the side, I guess. So 3.14 times 36, 24, 8, 18, 2, 4, 9, 4, 0, 3, 11, 113.04. So the area of the circle is 113.04. So again, for the third or fourth time, 192 is the whole area of this whole thing. I'm then going to subtract out the area of the circle, and I'll have the answer to the blue part. So 192 minus 100. I'm going to go ahead and just round 113.04 to 113, and you should get 79. 79 square centimeters. 79 square centimeters. All right, number 20. They're telling us the area is 80. They want us to find the base. So here we go. Area of a triangle. 1/2 base times height. So the area is 80. The base stays b, and the h is 16. So I have 1/2 times b times 16. So I'm going to go ahead and take 1/2 times 16, and that would give me, oh, did not mean to do that. That would give me 8b. So again, 1/2 times 16 would give me 8b. Now divide both sides by 8, and it looks like to me my base equals 10. My base equals 10 meters. Okay, moving on to number 21. Okay, this is a parallelogram, and how do you find the area of a parallelogram? Base times height. So they tell us the area is 104, so I'm going to put 104 for A. They tell us the base is 8. What they don't tell us, this should be an H right here, make that an H. What they don't tell us is what H is. So it seems like for me, I'm going to have to divide both sides by 8, which would be 13. And so my height has to be 13 inches. 13 inches. All right, number 22. Now, let's be careful on this. This is going to be a tough one here. In order to find the area of a trapezoid, it's 1/2 height base plus base. So for area, I'm going to put 126. For height, I'm going to put 12. And then b plus b, I'm going to put b plus 14. b plus 14. Now, remember, we want to simplify both sides, and I cannot simplify 126, but I can simplify this side over here. For example, first of all, 1/2 times 12 would be 6, b plus 14. Everybody see where that 6 came from? 1/2 times 12. All right, and then come up here and finish it. 126 is still 126, but look, I can now take this 6 and distribute it through my parentheses, times my b and times my 14. So 6 times b would be 6b, and 6 times 14 would be 84. And now let's solve for b. Let's subtract 84 from both sides to get b by itself. So we'll subtract 84, and that would be 42 equals 6b. And now let's divide both sides by 6, and 7 equals b. So there's the base, 7 feet to be exact. Wow, that's a problem. We're all cheering, aren't we? Whew, I did this whole thing straight through about the past hour. Man, my eyes are fried. So is my voice. Okay, A equals pi r squared, area of a circle. For A, I'm going to substitute 50. For pi, I'm going to substitute 3.14. And for radius, I'm just going to leave it radius. Okay? Now, we were solving for r, so let's get r squared all by itself. Let's divide this side by 3.14, and let's divide this side here by 3.14. Now, over here, they'll cancel, leaving you with r squared. Over here, I'm going to have to estimate on this, students. I think you're going to get out approximately 16 point something. I'm just going to put 16, okay? And now we take the square root of both sides. We want to get rid of this 2 right here. We don't want that 2. So we're going to take the square root of one side. But if I take the square root of one side, I've got to take the square root of the other side. And the square root of 16 is 4. And the square root of r squared is r. So your answer for number 23, the radius is 4 centimeters. 4 centimeters. And let's see here. I think that's basically it. I hope you're ready for your test. Test on Tuesday. If you want the 5 bonus points, make sure you have this whole thing done, and I hope this has been a help to you.